Okay, so I'm going to talk to you a little bit about NoSQL today. Can anyone just put their hands up if they are developing? Okay, so there's quite a few of you. Who's heard of NoSQL? Keep your hands up if you've heard of NoSQL. Okay, cool. Has anyone heard of Magic Seaweed? Yeah. Okay, keeps that a little bit easier. Okay, I'm Gavin Cooper. I'm the lead developer at Magic Seaweed. I'll talk to you about Magic Seaweed in just a moment. You can find me at Gavin Coop on Twitter, and there's my LinkedIn there as well. If you go on github.com/gcoop, that's where these slides are. Magic Seaweed is essentially surf forecaster surfers, so we take standard weather patterns and we basically take the data in and we repurpose it so the surfers can understand it and surfers know when to go to the beach to go surfing. We have about 1 million unique users per month and 4 million page views out of those uniques. Okay, so I'm going to try and keep it quite quick so that you guys can ask me questions afterwards at the end, because I think that's probably the easiest way to sort of wrap your head around NoSQL, because it's quite a fundamental shift away from MySQL. So to find out why NoSQL happened in the first place and why it is starting to trend recently, we really need to sort of go back in time and look at MySQL and why we're using that in the first place. So enter the DeLorean. So the first thing, ArtNet. No, I'm not really going to talk about ArtNet. I'm sure you all know what that is. Basically, everything starts with a problem. So NoSQL was created for the same reason that most of the awesome web apps today have been created, and the reason that those web apps we use, and the reason that those web apps are popular. They're created to solve a problem, or to use technology to make that problem go away. So to solve a problem, or to harness technology to make something more efficient and easier. So what did Google do? Well, Google decided that there are millions of web pages, but there was no easy way to search them. And AOL and Yahoo weren't doing very well, so they solved that problem. That's why we use Google, because they solved that problem. What did Facebook do? Before we had Facebook, we had to actually ring and speak to our friends, whereas now we don't actually have to do that. I mean, you're not going to come home on a Monday and check and phone 10 different friends. You're just going to check your Facebook feed. So they just made that whole social atmosphere incredibly more efficient. And on a side note to that, who's used Facebook's Graph API? That's pretty much just using NoSQL. I mean, using the Graph API and using CouchDB are very, very, very similar because they both use a RESTful interface. I'll get into that in a little bit. I don't want to jump ahead of myself. Okay, so back in the 90s, when we started using MySQL for websites, it was all about consumption of data and it was all about read of data. So MySQL was naturally a really good fit because it's very, very quick at read operations, providing you don't write to it too much. And it's very good at caching its own data as well. And obviously, we were using MySQL back in the mainframe era. We were using relational databases back then. The problem happened was when we moved into this new generation of web applications like Facebook, well, basically Facebook happened. Everyone started writing to databases. Everyone's contributing data, and there's millions and millions of people. And MySQL can't handle lots and lots of writes and lots of reads at the same time. All of the optimization that goes into making MySQL quick at read just sort of falls away. Okay, so let's look at our DBMS system, so MySQL for example. It was designed in the mainframe era when there was just one big server that filled an entire room and there was just a couple of users. And then we adapted it for the web. And when we adapted it for the web, it was brilliant because we only had really limited traffic, and like I said, most of the applications were all about read. It's relational, yet we use objects and documents in PHP. So we write tons and tons of PHP code to take all of these departed relational structures into actual documents, feed them out through an API, or feed them into our website, and then if we want to save it, we take that document on the form, we then decouple it again, put it into this nice abstract relational structure, and stick it back in the database. Well, why do we need to do that? There's no real reason for definitely doing it that way. And the other thing is that because of this, it doesn't horizontally scale really, really easily. So with MySQL, you have to have a read master and lots of reads, a read and write master and then lots of slaves, why can't we just have it so that it horizontally scales, so we can just add master after master after master? And it doesn't handle lots of concurrent connections. When we started, the original web pages that we built dynamically were very much a request-response system. So you ask for the page, you get the whole page back. And that whole page was built from top to bottom. Now we're moving into these sort of connected devices, and everyone's piggybacking off the back of an API. You're getting a lot more requests, but a lot more smaller requests. Now the problem with that is that MySQL's set up to have one connection at the start of the script, lots of SQL queries, lots of data returns, and the end of that connection. But if we're doing smaller requests, we need to be able to do more connections, which means we need more concurrency. So MySQL's not really optimized for doing that. And running clusters is hard work. Who here runs a cluster of MySQL instances? Exactly. It's probably because you don't need it, but even if you did, it's really, really difficult to start clustering MySQL together. I can show you, well, when we get onto NoSQL, you'll see that they just made that really easy. And we've used Memcache. So what happened was we found that MySQL was limiting our web applications, so we used Memcache. Does anyone know what Memcache is? Okay, so it's basically, for the rest of you, it's in-memory caching of a key value. So you do your result set, so you do your query, you take an MD5 hash to that query, you take the output of the result set, and you stick that in memory. So it all lives in RAM. So the next time you go and do the same query, it recognizes the SQL statement and pulls that data straight out of memory for you, as opposed to having to query the database again. That's just a key value store. That's all NoSQL is, a key value store. So if we were becoming increasingly reliant on Memcache, what people decided was, well, why do we need to keep going back to the database? Why don't we just make the Memcache thing persistent? And that, for me, is kind of when it became it started to click a little bit more together, and NoSQL started to sort of gain momentum. Okay, so the problem is real. It's not just trendy bullshit. I mean, there's a lot of trends that people go through in the web community, and a lot of those things can be attributed to just popularity and what other people are doing. But the problems for creating NoSQL and the problems for using NoSQL are real problems. It's not just something that everyone else is doing. Okay, so let's look at NoSQL. Now, I am a bit of a CouchDB man, so most of the stuff you're going to see is specific to CouchDB. However, the problems that I highlighted with MySQL are solvable by any NoSQL instance you might go for, whether that was MongoDB or whether that was Membase, for example. Okay, so CouchDB isn't just built for today's internet, it's actually built of today's internet. So it's got a RESTful interface. It stores JSON documents, and you use JavaScript and MapReduce. Basically, if you think of it like a massive database, but there's no structure to that database. But MapReduce is how you create the structure from that data pool set, okay? You just store the document. You don't need to worry about relationships. You just take a form, you serialize that form to JSON, and you stick it there. Really, really easy. Documents means no schema, so you don't have to design your schema up front like you would with MySQL. With MySQL, you say, I'm going to have a user, this user is going to have one address. In 10 years' time, when you've got 10 million users, and now you decide that they need 2 addresses, you've now got a really, really big headache, because you need to create another table, and then you need to find a way of migrating all of those users' addresses over to the new table structure, and in the same way of having absolutely no downtime whatsoever. Well, structures do change. That's just what happens. Structure isn't fixed. And the whole point of NoSQL is the fact that, well, let's not design the structure up front. Let's just let people store documents, and let's MapReduce the structure out afterwards. Because we can change the MapReduces as much as we want, and that won't have an effect on the data that's currently stored, and won't have an effect on how we're storing the data in the first place. And horizontal replication is just an easy win of this. If your code is already set up to accept an object that can have any attributes in it, then you don't need to worry about having 2 or 3 nodes that don't necessarily have exactly the same information or don't necessarily have exactly the same table structure. With like MySQL, for example, if you migrate one node, you need to make sure that the other 2 nodes are migrated at exactly the same time. Otherwise, your code is going to but you think it's reading from this database, but it's actually reading from this database, and it's got an attribute that it didn't realise was there, and it might fall over. It was built specifically to handle many, many concurrent connections. So it's built for today's internet applications, which are heavily reliant on the API, and that API is being hit lots and lots of times from very, very small amounts of data. And it was also built to work on things like Node.js, where people can be actually connected to the server persistently. It's built in something called Erlang, which is the same language that essentially runs the telephone switch that's at the end of your road. And what that means is it's been around for 20 years, the language. It's specifically designed to handle massive, massive loads. So we're talking tens of thousands of millions of connections at once, concurrently. And if one single connection drops, if your telephone conversation drops, your next door neighbour's telephone conversation doesn't drop. So here, if there's one connection or one query which is taking a lot of time, it's not going to take down the rest of the database. One of the problems we have with Magic Series is if one query sort of hangs and we get a backlog of hanging queries, the database will just go down because those connections are all dependent on each other. They're all interlinked. Whereas with using Erlang and using CouchDB, that just can't happen. It won't happen. And it's been proven not to happen in the telecoms industry. Okay, so what's in it if you don't actually need to scale? It's schema-free. So you don't have this problem with data migrations. It's more work to migrate data if you're in MySQL. If you're migrating data in MySQL and you're changing structure, you are going to cause problems because you're changing things. And it is going to cause downtime, or it's going to have a higher chance of causing downtime. And it takes more time. Because, like I said, you're writing all this PHP code to take fundamentally an object, depart it into 3 or 4 tables, stick it in the database, pull it out, put it back to an object. That's a load of PHP code that you just don't need to write anymore. So, less time, more money. Thanks very much. Okay, so you can say goodbye to lots of this, and lots of this. And that's a real query that I wrote. It's probably not, I'm sure you've got bigger ones than that. Okay, so we can say hello to an application like this. Does anyone use one of those? I recommend you check it out. It's a really, really, really sick application. It's entirely client-side, fully built in JavaScript, and it contacts a RESTful API in the background. Now, has anyone heard of Backbone.js? Backbone.js is basically a JavaScript MVC library, which is designed to work, designed to build something like this, designed to work with a RESTful HTTP interface at the back end. Basically, you're essentially on one page here. You never leave that page. The views change within that page, and the application changes as you interact with it, but you never leave that one web page. Just like when you're using Facebook, if you notice sometimes when you're using Facebook that parts of the page reload, but you're not actually leaving the home.php. The same thing is occurring here. And these things like Backbone.js and these model view controller JavaScript libraries are designed to work with a RESTful HTTP interface. Now, if you're using CouchDB, you've got one. You don't even need to write in PHP. You can write your JavaScript client-side application, talk directly to the database, and away you go. That's 2 languages as opposed to writing in JavaScript, talking to PHP, then talking to MySQL. And that's it. Has anyone got any questions?